All right, let's jump right in. Today we're going to break down something truly massive, a new digital inventory that's basically a universal blueprint for, well, for pretty much every regulated industry you can think of. But hey, before we get to the solution, you got to understand the problem it's trying to fix. You see, even in our super connected world, we're swimming in a sea of what you could call digital chaos. Our most important systems, they just don't speak the same language. I mean, really think about it. Why is it still so incredibly difficult for systems in finance or government or even in complex manufacturing to talk to each other seamlessly? It's this digital friction that gums up the works, creating huge inefficiencies and risks. It's a problem we've been trying to solve for decades. And that brings us to the core philosophy here. The source material makes this really bold claim right out of the gate. This isn't just another dusty binder of standards sitting on a shelf. Nope. This is designed to be a living, breathing, and most importantly, an enforceable part of our digital world. So, what is this grand solution? It's called the Saga Inventory. And the whole idea is that it's a unified blueprint meant to slice right through that digital chaos we were just talking about. At its heart, the goal is to create a single shared language. Just imagine for a second if a complex financial trade, a government permit, and a shipment of medicine could all be represented by digital objects that understood each other perfectly with no ambiguity. That's the big vision. The whole system is built on this one core idea called a canonical class. Now, what is that? Well, the best way to think about it is like digital Lego blocks. Each block is a standardized, totally executable definition for a real-world thing, like a bank account, a legal contract, or even an AI safety rule. And this slide, it lays out the process perfectly. You take all these existing industry standards, the words on a page, and you convert them into these concrete class definitions. Those definitions then create digital objects with rules baked right in, leading to a world where you know exactly how they'll behave. So you might be asking, how big are we talking here? Well, let me tell you, the scale is just massive. The sheer size of this blueprint is honestly one of the most incredible things about it. Just get a load of that number. That's not a typo. Almost 8,000 of those digital Lego blocks we were just talking about. Each one is a standard definition for a piece of our regulated world. This is not some small-scale experiment. This is a top-to-bottom re-architecting of how things work. And here's a quick peek at where those numbers come from. It's basically broken down into two major parts. You have Saga Standards, which covers all the industry rules and regulations, and then EWIGS, which, get this, stands for Executable, We the People, Integrated Governance Structures. That part is for modeling the actual frameworks of governments, like the US, Switzerland, and the EU. All right, so what do these nearly 8,000 classes actually cover? Let's do a quick run-through. Of course, it starts with the backbone of the economy, finance. We're talking about global payment standards like ISO 2022 and FIBO, which is the common language for financial instruments. And it's not just old-school finance. It tackles the biggest challenge of our time, AI governance. It includes executable versions of things like the NIST AI Risk Management Framework and even the EU AI Act. Then you've got these incredibly complex supply chains. It's modeling standards for tracking the entire life cycle of parts in aerospace and automotive, from a single tiny component all the way up to a full vehicle recall. And of course, it has to cover the super critical world of pharma and healthcare. We're talking classes for everything from drug serialization, under the DSCSA, to making sure patient data is protected under HIPAA. And believe it or not, it even gets into managing complex assets like intellectual property in music and film and physical assets in real estate. I mean, this scope is it's breathtaking. Okay, so we've covered the what and the how much. Now let's get into the nitty-gritty of how this system actually works, how it turns all those abstract rules into code that actually does something. First up, you've got Saga Standards. Think of this as the translation engine. It's the part that takes all those dense regulations and international standards and encodes them into those structured, executable canonical classes. So where do all these digital Legos actually go? They live and interact on an execution layer called SagaChain. This is the playground, the platform, where all those standardized blocks are designed to come together, talk to each other, and manage their state over time. Now, this slide looks a little technical, but it's really important. It shows the 5 core rules that make the whole system hang together. These principles basically ensure there are no broken links, that everything happens in a predictable way, and that the whole system is self-contained. You could think of them as the laws of physics for this new digital universe. They guarantee it's logical and totally reliable. Okay, that's a lot of technical stuff, but what does it all mean in the real world? Why should you or I care? Let's break down the impact for everyone involved. So, what's the bottom line here? Well, for regulators, it's a game changer. It promises a world where checking for compliance isn't a subjective process, but a predictable, easily auditable fact. And for businesses, it means slashing the cost and the headaches of trying to make different systems work with each other. And thinking bigger for entire governments, this could open the door to things like digital twins of their own legal and operational structures. And for anyone building AI, this is huge. It offers a way to enforce safety and governance, not as a suggestion, but as an unbreakable code-based rule. And really, this one quote from the source material just nails it. It's all about this massive shift away from governance that's based on paper documents and human guesswork to a new kind of system where the rules are literally baked into the infrastructure itself. And so that leaves us with one last really big question to chew on. This project is a blueprint for a world where the rules are no longer just static words on a page, but are the living, breathing code that actually runs our most critical systems. What does a world like that actually look like?